Hey guys, previously we explored the concept of control flow, which essentially provided us a way to choose which blocks of code we want to execute based on the outcome of certain tests. We saw that even with loops, although they might not look like they're performing the test necessarily every time, they have to perform some tests at the beginning of each loop iteration to determine whether or not to continue on or to exit out of the loop. Well, now we're going to explore an even more convenient mechanism to choose which blocks of code we want to execute, and we won't have to perform any tests to do so. This is all going to be done through the use of functions. Now, there's a couple of great things about functions. The first is that we can just define the function once and continue to call upon that function over and over again. So that way, if our function is complex and contains many lines of code, we don't have to write those lines of code to perform the same function every single time. We can just call upon the function name, pass in any parameters if necessary, and let the function that's already been defined do all the work for us. The second great thing about functions is that they provide a nice sense of organization to our code. So we can kind of group together nice related blocks of statements so that it's easy to find the pieces of code that we want, because we know, for example, function A is going to perform this task. So if for whatever reason task A is messing up, we know it's probably something to do with function A. And finally, we get very fine-tuned over exactly when and where we want to execute the code, rather than having to rely on the outcome of tests or just kind of printing the code willy-nilly. So the topic of functions is actually a fairly straightforward one. It's probably easier than control flow, and we're only going to really explore a few concepts in this topic. So the first is just going to explore some basic function syntax in Python, and we'll take a look at how to not only create functions and fill them with code, but also how to call upon them and run the code inside or execute that code. Then we'll take a look at parameters and finally finish up with return values. Now, parameters are just values that we pass into a function, and return values are values or a value that a function might output once it finishes running. So I think we'll get started with an interesting example, and this is basically going to take in an array of numbers, this function will, and it's going to multiply all those numbers together, and then it's going to output the result. Now, I wanted to do a sum function, which is going to add all the numbers together, but that function already exists. We can actually just call sum and then put in a bunch of numbers. But like I said, we want to keep things different, so I'm going to have kind of a multiply function. So because Python is pretty easy to run, we can actually do all of this stuff without the use of a function. But once we put it inside of a function, we'll see that this is going to be a much better way of doing things, and that's going to be to use functions as much as possible. So we'll start off with just some variables here. The first is just going to be our num array, and I'm just going to set this equal to an array of numbers, so we'll just have the first 5 numbers here. Okay. And then we can have a variable called total or something. I'll just set this to 0 for now. So hopefully, from our discussion on control flow and on arrays, you guys have a general sense of how you might go about doing this. Essentially, we'll use a loop, and we'll just take each of these elements and multiply it by the total, which I guess should actually start out as 1. Okay, and at the end, we can just print that out. And in fact, print is itself a function that we've been using all along. But more on that in a little bit. I just want to set up our basic loop. Let's just go for num in num array. We are simply going to say total, multiply equals num, and then at the very end, we can just print out the value of total. Let's go and zoom out. And before we run this again, I'm working in another file. This is called functions.py. I have it separate from my control flow one, as you can see. So let's just run functions instead. If you want to choose the same file, that's fine. Again, just comment out all of the old code. So running functions, I get the value of 120 printed out, which is correct because 1 times 2 times 3 times 4 times 5 should be equal to 120. Now, the annoying thing is that every single time I want to execute this code, I then have to call on this, and I have to basically copy and paste this code over and over again. Now, this isn't a ton of code right here, but imagine if our function had, let's say, like a dozen lines of code, and every time we wanted to execute that code, we would have to write out that same dozen lines. Well, wouldn't it be much easier if we just stuck this all in one function, so that every time we want to execute the code, we simply call upon the function like we would our print statement here, and execute that code within? So the way we would go about doing this is to start with def for define, and this is how we start our functions. Now, functions need a name. This one is going to be called something like multiply. Okay, following the name come some brackets, and usually we put our parameters inside of these brackets, but in this case we're not going to have any to start off with. We can add them in later. Now, similar to control flow, at the end we want to add our colon to signify the end of the function name and parameters, and then we want to put the function body within the function itself. So what I'm going to do is actually take all of this stuff here, And actually, you know what, let's take the whole lot of it. I'm just going to cut it and just paste it right within our multiply function, and I'm just going to squish this all together. And that should be good for now. Now I'm not including num array in my function because this is something that might change later on. If I put num array within my function, then it's going to be performing the same operation on the exact same array every single time. This way I can perform multiply on num array. Later on I can then change num array to be some completely different array, such as, 5, 6, 7, and 8, and then I can call multiply on that function again. Or rather, I can call multiply on that array. So now let's see what happens if we run this code. Well, nothing's printed out, but why is nothing printed out? We've clearly said print total in here, and we know that this has been working before. Well, the problem here is that we haven't called upon the function, we've only declared it or defined it. So if we want to actually call upon multiply and execute all of this code, we have to make a call to it simply by saying multiply. Okay? So if we go to run this, now we get 120 printed out because this call to multiply is going to go to multiply's definition. It's going to pass in any parameters, in this case there are none, and then it's going to execute all of the code found within, so it's going to total everything and then just print that out. Similarly, if I then called multiply on this num array, then I should get yet another value being printed out. So I run this, and then as you can see, two different values because num array was this value up top and then change its value later on. So hopefully you can start to see the benefit of using these functions. I can just call on multiply every single time rather than again having to write out this code for each case where num array changes its value. Now, this function isn't very flexible because for a start, we are not taking any parameters, and also we're only taking in num array. So if we define a different kind of array, such as, let's say, something slightly different name, number array, and I set this equal to like 10, 11, 12, 13. And then I call multiply again. Well, multiply is not going to do anything with number array because I've said that our multiply function is only ever going to work on this num array here, which is going to be this variable. So this is where parameters can come in really handy. If we added a parameter to this function, then we eliminate the need for this extra variable altogether, and we can choose to execute this function on any array we want as long as we pass it into the function when we call upon it. So I'm going to go ahead and completely redefine, well, not completely redefine our function, I'm just going to modify it a little bit, and I'm going to have it take in a variable called num array. This way I can actually eliminate this, and I can just get rid of all of this stuff here. So now this should give me an error or some kind of annoyance saying, well, we're kind of expected to take in some kind of a parameter here. So why are we not taking anything in? So now you'll see if I start to call multiply, now I need to enter in some kind of number array here. So in this case, I'm just going to enter in some random array. Let's just stick with what we had before, just the numbers 1 through 5. So if we go to run it, we should get the same results before 120. Okay. Similarly, if I ran it with some different numbers, I think we had 5, 6, 7, 8 was the next one, and we had like 1600 or something. Then I go to run it, yep, 1680 again. So we know that this is working exactly as it should. So the benefit of adding this parameter in is that we don't have to declare those extra variables anymore. And now every time I call upon multiply, all I need to do is pass in the exact values I want to multiply together, and then I'm good to go. So this is a much better way of defining this function than what we had going on previously. So the thing we put in here is called a parameter. This is essentially something that we have to pass into the function every time we call upon it. And it's also something that we're using clearly in the code itself. So what this means is when we call upon multiply and pass this in, num array takes on this value that we pass in. So now we're saying for num in this array 5, 6, 7, 8, we'll execute this code here. Similarly, if I passed in some completely different values, so like 54, 6, 3, and 10, then num array takes on these values here. Now I'm not going to run it on this because that'll produce quite a large number. And we've already seen how it works anyway. Now this function is pretty good, but we can actually go one step further and make it even better, even more flexible. So right now it is totaling everything just fine, and it's printing the total, but that's it. It's not like we can actually do anything with that total. So instead what we can have this function do is return something. It can return the total so that we can do whatever we want with that total later on. We can add something to it, we can subtract something from it, we can multiply it to something else, we can print it out, so on and so forth. So all we really need to do here is get rid of this print call, and we're just going to say return total. So now our function, once it finishes executing, it'll do this, it'll do our loop, it will exit out of the loop, and it will get to this, and it will basically say, okay, we're going to return this value, we're going to spit some value out once we finish executing. So now, I'm going to call on my function, but I can also store the result because it's returning a value in some kind of a variable. So I can say something like result equals, multiply with these numbers. I'm just going to go back to the simple version, 1 through 5. And then at the end, I can print result if I want. So as you can see, I go to run this, and now I get 120 being printed out, even though I'm not actually printing anything in the function itself. That's because this function is executing on this array, due to that being the parameter, and then it's going to return the total value and store it in a result, which we're then printing. If we wanted to do the shorthand, we could actually just print a call to multiply here. So I could just take this, copy it, and paste it in, and eliminate the need for my result variable, and it will do exactly the same thing. So now that we've covered return values and parameters and the basics of functions, that is pretty much all we have to discuss on this topic. Like I said, it's a bit easier to understand than some of our control flow stuff, particularly the loops. It's essentially just a convenient way to store our code. Just to quickly summarize, if we want to define our function, we start with def, we give the function a name, the brackets here with any parameters, the colon to signify that the function body is beginning, and then we put the function body in here, basically the code we want to execute when the function is called. We call upon the function by simply typing its name. In the brackets beside the function, we just put the values that we want to pass in as the parameter. Now, parameters are values that we pass in that can be used throughout the function body itself, just like any other variable, but they only take on a value when we pass that value in as a parameter. We can also have functions return values, or basically output something once they reach this return statement. And by the way, this return statement doesn't have to be at the end of the function. We just need to make sure that if the function is going to return something, it will always return something in all possible cases. We didn't in these examples. Well, I guess actually we did with the for loop, but we can make these functions as complex as we want by adding in lots of control flow. So we can add in loops, as we did here. We can add in stuff like if statements. We can even make calls to other functions within the function body itself. Okay, just know that if you're going to return something from a function, when you call upon it, a result will be outputted, which we can then use. In this case, we're simply printing out, but we could use that value as we would any other variable. Otherwise, that wraps up functions nicely, and we can move on to our next topic, which is going to be classes. So play around with functions a little bit. Try to simulate some scenarios in which you think you might need functions. A good place to start would be some kind of a simple video game. So implement stuff like player movement, what to do if the player collides with something, or just some simple game mechanics. That's always a fun and practical example to go on. So once you're familiar with functions, let's move on to classes. What's up, guys? Having just finished our discussion on functions, I think we now know enough to start taking a look at our final topic, which is going to be on classes and objects. So this is not just going to be our last topic, but it's also going to bring together everything that we've learned in the previous 4 sections. So if there's anything from those sections you're unsure about, definitely go back and watch the videos before watching this section. That being said, this is going to be a nice way to bring everything together. So some of it will be review, and some of it will be covering entirely new concepts. So we'll divide our discussion on classes and objects into our 4 or 5 main parts. So we'll get started first by talking about what a class is, what an object is, and what the relationship is between the two. Then we'll take a look at how to add properties to our class. We'll do this with variables. Then take a look at how to add behaviors to the class. This will be done through the use of functions and methods. Then we'll start exploring the concept of using initializers, which are a special type of function that help us create new instances of classes. So I'll explain what these mean a little later on. And finally, we'll finish up our discussion on this topic with the concept of inheritance, which essentially provides a way from one class to inherit all of another class's attributes. Now, as always, I've started a new file. This one is called classes.py. So if you want to start a new file, then I encourage you to do so. Otherwise, just comment out all of the old stuff. And for me, I'm just going to make sure that when I run my new file, I am indeed running classes rather than any of the previous ones. So running this will just produce a blank run screen. So let's get started by talking about what classes and objects are and what the relationship is between the two. Now, so far, all of the values we've seen have kind of been just single values or multiple values in the case of stuff like arrays and tuples. But that's really all they're holding is a specific value rather than representing an entire object. So, for example, if we use a string that represents, let's say, a pencil or someone's name, well, that string isn't representing the object itself, it's just the name that we've given to the person or the name of the object. Similarly, if we store a number within a variable, that's not representing an object, that's just some value that that variable currently holds. And the same can be applied to tuples and lists. These are just kind of lists of values or tuples of values. These aren't necessarily objects themselves. Well, this is where things are going to get a little different because we can use objects to represent entire real-world objects, such as a bicycle or an animal, or in the example we're going to be using, an entire video game character. Now, objects typically are represented with state and behavior, and so state can be interchanged with properties here. So state and properties are represented with variables, and these will hold individual values that will help to build our object up. And then the behaviors of the object are represented through the use of functions, or as they're referred to once they're in classes, as methods. So from now onwards, I want us to start thinking about a video game character and what kind of properties or attributes this character might have and what behaviors he or she might be able to carry out. For example, some straightforward and simple properties a character might have are something like a name, maybe a character has a number of hit points, maybe a character has a certain position on the map, a certain strength or something, and so on and so forth, whereas some behaviors might be to move forwards or backwards, to change the current hit points, and so on and so forth. So try to think about some properties and behaviors a character might have. Now, as for what a class is, well, the class is just a code representation of the object. So we can kind of think about the class as being the blueprints that represents the object, and then the object being the value of that particular class. Specifically, an object is considered an instance of a class. So, whereas a class might define all of the behavior that an object should have, as well as all of the properties that an object should have, the object is how we actually store specific values in those particular properties. So, to help demonstrate this point, why don't we launch right into an example? We'll start by just creating a basic video game character class, and then we can start to add more properties and more behaviors as we go. So, the way we start with class declarations is by typing class. We give the class a name, and this naming convention is a little different from usual. In this case, we're actually going to capitalize the name. So we'll call this something like game character. And by the way, I just want to keep this fairly generic right now because we're going to get a little more specific later on. So these should be attributes that would be common across all game characters. So whether those game characters are non-player characters or player characters or just something simple, okay? So with the name, we put the colon, and then we put the actual class definition underneath, just like we would any other function or control flow and so on and so forth. So some properties a game character might have would be something like a name, okay, which is just going to be a blank string for now, or additionally, we can actually say none. It doesn't really matter, but I'll just say a blank string just because we want to communicate that this should be a string and not a number. A video game character might also have something like a maximum number of hit points or max hit points. Just going to set this equal to 0 for now. Similarly, they'll have a current hit points value. Okay, and this is also going to be 0 for now. And then the character might also have something like an X position. So I'm not going to bother with X and Y positions. Let's just assume that this is just kind of moving left and right for now. Just going to really keep things simple, hence why I'm only going to stick with these 4 attributes for now. I know a game character could have dozens and dozens of different attributes, and if I were to build an actual game, obviously I'd add a little more than this, but we're just trying to keep things simple and straightforward as possible. So, as of right now, we've created a class, and we've given some properties to this class. Now, these are represented with our basic variables as we've seen before. Alternatively, we can actually have lists as our value. So if I had like an inventory of items, that might be a list of items, okay? Also, we can have other classes or objects as global variables or as properties of a class, but we might save that for the end. Now, note how none of these hold any real values right now. I mean, not to say that zeros aren't necessarily real values, but they don't really represent anything in the context of current and maximum hit points. They might in an X position, but we definitely shouldn't have max hit points of 0. Similarly, this is just a blank string for the name right now. Well, we'll actually use what's called an initializer to give these some values, but I'm going to come back to the initializer a little later on. Let's first just get this class up and running with some behaviors, then we'll come back to the concept of initializers and instances. So what behaviors might our video game character have? Well, most of the functions and the methods that we add inside of a class are used to modify the character's state or modify the properties. So these are often called state instead of properties because they help to represent the current values that a particular object can hold. We're going to see this a little better once we start talking about the objects themselves and instances. Just know that when I use the word state and property, I'm kind of talking about these global variables up here. So let's just create a couple of pretty simple functions. One's just going to change our current hit points, and one is going to change our X position. So we can create a function starting with definition, and this one is just going to be called something like change hit points. Okay, and we're going to take in some parameters. Note the use of the word self, so I'll get back to this in just a second here. And I'm just going to add an additional parameter. Just make sure that you don't delete this. We do need self there. It should add automatically anyway. So rather than making this function a set current hit points, I'm actually going to add in or put in a value that will increase or decrease our current hit points. So I'm just going to say something like change in hit points, and in our function definition or in the implementation itself, we're just going to put something like self dot. Okay, we have to do self dot current hit points if we want access to this, and again I'll explain why in just a second. And we're just going to say plus equals change in hit points. So essentially this function, if it's called on an instance of game character, is just going to take in some value, let's say for example 50 or 100, and it's just going to add that value to the current hit points value. So if the hit points are 50, we add 50, we pass in 50 into this function, our current hit points would then be 100, assuming that everything worked out well here. Now note the use of this word self. So self refers to the class that we're currently working in. For example, we're working in game character right now. Everything here belongs to a game character class. This means when I call self.current hit points, I'm referring to this current hit points up here, or the current hit points that belongs to this particular class. Note how if I actually just try to type in current hit points, that's not even an option that I can work with. Okay, I have to call self dot if I want access to any of the functions or the properties of this class. Similarly, any of the functions that belong to a particular class begin with self as their first parameter. Now that's just something that is added in automatically and is a property of any of the classes that again belong to a specific function, or of the functions that belong to a specific class. Whereas we saw before, if we were to have some kind of function here, random func, okay, then it would not require the use of the word self. Okay. In actually a lot of languages, the self keyword is unnecessary in some cases, but in Python we actually have to use that word. Okay, so with this in mind, we'll design our other function, which is going to do a very similar thing for our x position. So this can be change position or change pos, that works. Okay, we'll open up the brackets again, self added automatically, and now we're just going to say change in x pos. I guess I should be specific, this is changing our x position. Okay, and we're just going to say self dot current, or actually it's self dot x position plus equals change in x position. Alright, so for a lot of these variables, you'll often see something like this. You'll see the global variable itself, and then you'll see functions that do something like this. For example, get x position. Okay, and this is just going to do something like return self.x position, x pos. Similarly, you might see something like this, def set x position. Okay, and again, this is probably going to take in some new value, so new x pos. And then we could just say self.xpos equals new xpos. Okay, so this is one good way of doing things, but it's not necessary to do this 100% of the time. For the most part, the reason we would create these separate getter and setters, as they're called, because they're just getting a value and setting a value, is if we're making these variables private. Now, private variables are essentially only accessible within the class itself. So if I declared some of these variables as private and then tried to access them outside of my class definition, then I couldn't do so. They don't even appear as options. For the most part, making variables private in Python is actually discouraged. Whereas in some other languages it is encouraged. I know in Java, as much as possible, we should try to restrict access to variables, but in something like Python, which is kind of weird, it's encouraged to make everything accessible as much as possible and avoid the use of private variables. If we really want to make variables private, we actually precede the variable name itself with these two underscores here. And if we want to indicate that these variables are accessible, we can change their values, but we should probably use these separate functions to do so. We can actually just add the single underscore, and this is not technically restricting the access, but it's kind of saying that be careful if you are trying to access this variable. If you want to use this, then probably create these separate getter and setter functions. So because I'm actually okay with these being accessible everywhere, and I don't really want to create these separate getter and setter functions for all 4 of these variables, I'm actually just going to get rid of this and make these variables available everywhere. Okay, that way we can access them directly by calling on an instance name dot name or dot max hit points or so on and so forth, and just get and change the value that way. Okay, so when we're changing our hit points, we should probably place some restrictions on the maximum and minimum hit points, minimum values that a hit point can take on. As well, we should probably restrict the x positions to maintain within the boundaries of some kind of a map, but I don't know how big or small the map is, so I'm only going to focus on my change hit points for now. So in this function, we might want to say something like if, and we can say something like self.current hit points is greater than, our self.max hit points? Well, in this case, we just want to set self.current hit points equal to self.max hit points. So this is essentially saying that we can never go over our maximum number of hit points. And then similarly, we can say something along the lines of elif self.current hit points is less than 0. Okay, well, in this case, we're just going to say self.current hit points equals 0. And there'd be additional behaviors such as deleting lives, removing the character from the game, and so on and so forth, but I'm not going to implement that here. Again, for two reasons. One, because I'm trying to keep things simple, and two, because I'm actually going to add in some of that behavior a little later on, where it will be a little more appropriate. For now, I just want to kind of restrict the values to remain within a certain range. Okay, so we've essentially added some properties and some behaviors to this class. So we can now change our character's hit points, we can change a character's X position, and it's as if this character is healing up or being injured and then moving about the map. As well, at any point in time, our character will have these 4 attributes with some actual values in them. So, how do we set up a new instance of a game character? So essentially create a new game character object, because this is just the class definition right now. Well, to do so, we need what's called an initializer, which is a very special type of function. This will help us to create what are called new instances of game character, and then populate some of the necessary values. So right off the bat, our game character typically will have some of the values set up as soon as he or she is created. So there should be stuff like a name, maximum and current hit points, and a certain position on the map, and that's why I added only these 4. Additionally, we might have something like an inventory of items, which should probably be initialized to be empty, as our character, when first spawned, probably won't have anything in the inventory. Similarly, there'd be maybe like a skill set or a certain amount of damage or so on and so forth, or strength that a character might have. These are going to be initial values that a character needs to have as soon as it's created. Okay, and we're going to use our initializer to help set that up. So if we actually start typing in def init, you'll notice that we get a few different functions being pulled up. So we actually want this one here, which is just going to be our very basic initializer. Now note right now that it's not taking in any parameters other than self, because of course self always has to be there. Well, what we want is to actually pass in some values for these variables, because we want to set the values as soon as the initializer is called. So we're just going to take in some parameters like we would any other variable. We'll take in a name, we'll take in a maximum hit points, and we'll take in a current X position. So to set these values, we'll simply say something like self.name equals the name that we're passing into the parameter here. We'll say self. And note actually that this is an F. Okay, so these belong to the class itself. So if I type in max hit points, then I still know that it's belonging to this class, and then I set equal to max hit points here. Note that it's a P, because this is a parameter now. Okay, so that's how I know I'm talking about this max hit points, especially because it's self.max hit points, this one, and then the max hit points I'm setting equal to is just this one here. Okay, self.x position is now going to be our x position we pass in, and we just need to set our current hit points next, so we're actually going to say self.current hit points is just equal to our max hit points as well, which makes sense. We want to start our character out at 100% health. Alright, so that's our basic initializer. Every time we create a new instance of game character, we call on this initializer. I'll show you how to do that in a second. Then we pass in these initial values, and it just sets our character up as if he or she was first spawned and just has those kind of base values. So with this initializer defined, we can now go ahead and create some new instances of our class. So let's just get rid of that. We'll be outside of our class declaration right now as well, making sure that we are not indented or using spaces at all. And we'll store this new instance in something that's very similar to a variable. So I'm just going to call this something like new game character. Okay, and I'm going to set this equal to, if I start typing in game character, note this class comes up. So I type that in, and it's as if I'm using an initializer function. I'm just going to open up the parameters like I would, and it's going to ask for a name, maximum hit points, and an X position. So I'm just going to start by typing in my own name. I'll give this guy, let's say 100 hit points to start off with, and we'll start this player at, or this character at position 1. So now we've successfully created a new instance of our game character class, which is an object, and this is our new game character object. So you'll note that it looks very similar to a typical variable declaration. It's kind of as if we are passing in the value of game character, and it just has each of these values stored within it. So the value of this class right now is kind of the sum of all of these properties. So this is essentially called on our initializer. Note how we're passing in a name, a maximum number of hit points, and an X position. So as of right now, our game character has the value here as Nimish. It has the maximum hit points as 100. Same with the current hit points, and then the X position is 1. Okay. So if I were to print these values out, So print, first of all, so if I were to print my new game character, I don't really get anything printed out, but I could create a separate print function to do so, but let's just print out the attributes one by one. So game character dot name, okay, we can print new game character dot current hit points or maximum hit points, doesn't matter, let's just do the current hit points, and then we can print the new character dot exposition. So just zooming out, going to go ahead and run this, and as you can see, I get my appropriate values being printed here. So this is how we access the values within a class, and we access the functions in exactly the same way. So for example, if I wanted to change my hit points, okay, try to change it, let's say we'll try to subtract 50 from our hit points, maybe we sustain some damage. So I'm going to say new game character dot change hit points, okay, I'm going to add in a change in hit points, in this case negative 50, and now I'm going to print out my character's hit points again to see if things have changed, so current hit points. So we'll give this a run. And as you can see, my current hit points are now 50, okay? And if I try to set that over 100 or less than 0, the restrictions would be put in place and make sure that doesn't happen. Okay, so we've used some functions to modify the values. We can actually modify the values directly by saying something like new game character dot exposition equals, let's say 50 for some reason, and then I want to print out my new character dot exposition. Okay. I'll go ahead and run that, and you can see the exposition is now 50 as well, and this is certainly one way of doing things. The reason we actually have direct access to these variables and can change their values is, again, because I'm not making them private, I'm not really restricting the access at all. So the only reason we would want to restrict the access this way is if we don't want to be able to do this. We don't want to accidentally change the values of that particular object, and just want to be careful to use the separate functions, such as getter and setter functions, to help us to do so. So at the end of the day, it really just comes down to personal preference, how you want to do things, but like I said, Python does kind of encourage you to make things as open and as accessible as possible, which is kind of different from some of the other languages. Now, so far we've covered basically 4 of our 5 main concepts, so the only one that we have left to explore is going to be the concept of inheritance. So inheritance is basically one class inheriting all of another class's properties and functions, so methods, as well as the initializers. Now, this is important because it will save us having to essentially implement the same class twice. As well, the subclass, which is what inherits from the superclass, can define additional properties and additional functions of their own. So the reason I made my game character fairly generic and just have stuff like change hit points, change exposition, haven't made any special behaviors here except to restrict this within a range and some very simple properties, is because I now want to create a new class called player character. So typically in a game we might have player and non-player characters. The player character will generally have a lot more properties, a lot more functionality than a non-player character because obviously we're going to be interacting and controlling that character. So we want a player character to be able to have everything that a game character can have, but it wants to have more as well. There might be more behaviors, more properties, and it might actually want to change the way these functions work a little bit. So let's start by creating our subclass of game character. Again, I'm going to call this player character. We'll define some properties of its own, and we'll even what's called override a couple of the methods, which is essentially going to be providing a slightly different implementation for some of these functions. So I'm going to define it right below our original class, the game character. And we define subclasses in a very, very similar way. I'm going to give this a name, player character. Now I need to note that it is a subclass by putting in the brackets the name of the superclass, in this case, game character. Okay, so now if you'll note, I'm just going to add one property so that this goes away. And this is just going to be a number of lives. So I'll just put lives. Whoops, not livers, we want lives. And I'm just going to set this equal to 0. Okay, so now, because this has inherited everything from game character, so not only the properties up here, but also this initializer and these functions, I can actually create a new instance of my player character. So just going to get started actually by deleting all of these because I don't want them, and I'm going to create my new player character. Player character this time. This is going to be a player character instance. We can open up the brackets here, and again we can use the same constructor as before where we put in the name, max hit points, and exposition. So if I put in some name, let's go with something like Katie. I don't know, first female name that came to mind. This one has 150 hit points this time and starts at exposition 10. Now again I have access to all of the same properties. This time I need to call new player character dot, for example, my current hit points, and if I want to print this out, then I could do so. So let's just run this. I get 150 being printed out because I'm now printing my new player character's hit points. But this would be kind of pointless to do this if I didn't go to define new stuff within this class. And this is kind of the whole purpose of this subclass-superclass relationship and inheritance, is the ability to get everything that a particular class has and then implement more stuff, okay? Again, the whole idea behind this relationship is to eliminate the need to implement exactly the same stuff multiple times, because that's actually pretty bad code practice. If you're doing the same stuff, you're writing exactly the same code over and over again, there's probably a more efficient way to do that, if that's the case. Okay, so let's just go about and redefine some of these attributes here. So, for example, our new player character might have lives and also might have, let's say, an inventory. Inventory here. And I'm just going to set this equal to an empty, you know what, let's make it a dictionary because it makes a little more sense. Actually, you know what, in the interest of keeping things simple, I'm just going to actually make this an array with a bunch of items in it. So now my player character has these additional two attributes, which I can access. So, for example, new player character dot lives, okay, I can access that. But what I can't do is say new game character dot lives, because that doesn't exist on our new game character. That's only a property of player character. So whereas the subclass gains everything that superclass has, not necessarily the other way around. So my goal here is to set these two values up. So in order to do so, I'm going to need to provide a new definition for my initializer, because I want to initialize my inventory with maybe a couple of default items such as like a shirt and pants or something. And then we also want to set this character up with a few lives. Obviously having 0 lives is bad. So the way we would do this is by defining yet another initializer. So def init, okay, we start with self again. We want to take in the same 3 values as before, but we want to take in some additional values, or at the very least, set these values up. So actually, we won't take in some additional inventory values or additional number of lives. We're going to set each of these player characters up with, let's say, a default 3 lives and a default inventory with 2 items in it. So we'll take in a name, we'll take in a max hit points, we'll take in a current X position. And now we're going to need to first call upon the Superclasses Initializer and then set up our additional stuff. Now the reason we're calling on the Superclasses Initializer is again to avoid writing the same code twice. Now I call on this and it's actually giving me this error saying it needs to call our superclass. The way I get around this is by calling my super, okay, and note how, oh wow, I actually filled it in all for us automatically. So we need the super keyword in the brackets. We need the class that we're working in, player character. We need the self keyword, and then we call .init, and then we pass in these same values like we would if we were calling on the initializer here. So in this case, the values we'll be passing in will be our name, our max hit points, and our X position. So now essentially what this will accomplish is when we call on our initializer, we're still passing in name, hit points, and X position, and now it's essentially going to invoke the superclasses call to this, and it will perform the same initializing as before. But now we can define additional stuff such as self.lives, see if I can actually spell that, equals 3, and then I can say something like self.inventory equals just some array with some items, and I'm just going to say something like shirt and pants. Now honestly this would be best represented with the dictionary because then we could have quantities of these items, but let's just keep things simple. So before, if I were to just use my default superclasses initializer, and I'm actually just going to comment this out quickly, and then I were to print my new player character's lives, okay, and let me just zoom out and run this, no, I get 0 here. Okay, that's because I'm not using this initializer yet, and I just set lives up here to be 0. But now let's say that I do want to use my actual initializer here, so I'm just going to uncomment this. So lives should have the value of 3 because we're using our subclasses initializer here, which is calling the superclasses initializer but also setting this stuff up. Then if I now run this, I get the value of 3 for the number of lives because we're using this initializer, and at the same time I still get 150 because I'm using my superclasses initializer as well in this call here, super.init. And that's how we call anything in the superclass, is just going to be the super.init, and that will just call super.whatever it is, change hit points, or change X position, or name, and so on and so forth. And that's how we access the superclasses version of that. So, let's build up our player character class a little bit more. We'll define a separate function that will just add an inventory item. So this can be something like add inventory item, okay? And we can take in a new item. New item, actually should add the space there, and I should really be adding spaces here, it just makes the code a bit more readable, just kind of trying to save some time. So in this case we are just going to take our self.inventory.append, and we're just going to append whatever new item's value is to that inventory. Okay, so now this is going to be an additional function only available to my player character, not to my game character. If I try to call upon, let me just scroll down here. I need to go down. If I try to call on my new game character dot add inventory item, doesn't exist, whereas my new player character dot add inventory item does exist. Okay, so I can call on this. I can pass in something like maybe our character picked up like an axe or something, and so if we were to print out the inventory, an axe would be added to that. Now the final concept I wanted to show you is kind of method overriding in Python. And this is the ability to take an existing method from our superclass and change its implementation very slightly. So I'm going to do this with change hit points because I now have this lives attribute. So basically when I change my hit points to 0, I'm going to subtract 1 from the lives, and then I'm going to change my current hit points back to 100. I'm not going to deal with the code that will delete the character if the current hit points are 0, because something like some random animal that's running along the map, that'll be a non-player character, and when that hit points reach 0, that character is probably going to die and disappear from the game. Our player character should do the same when our lives reach 0. So when our current hit points are 0, we'll subtract 1 from the lives. When the lives are 0, we'd remove from the game, but we're not going to implement that code. We're just going to do the subtraction of the lives. So that means I want this same function because I still want to restrict my values, but I want to provide additional functionality to it. Now that would be called method overriding, and the way we go about doing this is by calling first on the same name of this function here, so def change hit points. And I can go about doing this two ways. I can provide a completely different implementation if I want, or I can call on my superclasses implementation to execute this code and then provide additional code. And I'm going to do the second option because I don't really want to repeat myself. So I'm going to call on my super, okay, dot. And, oh, actually, I need to put in these brackets here, just like we did up above. So we're going to go super player character, comma, self. Okay. Now if we call dot, then we change our current hit points. So I'm just going to put the change in hit points in here. Now, before I go ahead and change anything, I'm just going to go ahead and make a call to change hit points and then run this. So if I call my new, actually, let me zoom in, make it easier for you to read. If I call new player character dot change hit points, and I'm just going to subtract 50 from my current hit points and print out whatever value this currently holds. So let's go here. I'm actually going to delete those other prints. Okay. So if I run this, then I get 100 printed out because we started with an initial 150 and we're subtracting 50 from it. The same could be said for our new game character. So if we took new game character and we were to change the hit points again, change hit points, just going to subtract 50 from there and print that out. Print new game character dot current hit points. So we get 50 and 100 because we started 100, subtracted 50, and for the second one we started at 150 and just subtracted 50 again. But now I'm going to provide a slightly different implementation for this, and that's going to be to subtract 1 from our lives, okay? So maybe to help demonstrate this point, actually, it would be easier if I added a lives variable to this. So I'm just going to add lives to my game character, okay, and then just set up lives, so self.lives equals, you know, no, I'm not going to set up in the initializer because that's going to cause problems later on. I'm just going to set it up to be 1 right now here. Okay, so we'll start off with 3 lives for our player characters, 1 for just a regular game character. So now what I'm going to do in my change hit points is I'm going to make a call to this, and then I'm going to say if our self.current hit points is less than or equal to 0, and it shouldn't be less than because we've called on this, we are simply going to take self.lives minus equals 1. And then we can make the change in here. So if self.lives is less than or is less than 0, we can just say something like self.lives equals 0, and that should be good to go. So also, if we are subtracting 1 from our lives, we simply want to change our self.current hit points, then back to maximum hit points, so self.max hit points, just so that we can kind of reset that value. So now we have a lot more going on in our change hit points. We're dealing with subtracting 1 from our lives. But keep in mind, this is actually only in our player character class. This implementation does not exist in our subclass, in our superclass. So now let's see what happens when I call my change hit points for both my player character and my game character, and then print out the number of lives these characters have. So I'm just going to print my new game character dot lives, okay, and in here I'm going to print my new player character dot lives, okay. And if I go ahead and run this, then note that, oh, this actually isn't enough to change the lives, so let's just subtract, let's say, 200 from this, and 200, and this will be more than enough. So if we go ahead and run this, note that my number of lives here is not changing, and my current hit points is actually still at 0, but here my current hit points have reset to 150, and I've subtracted 1 from my number of lives. So this means that we're still calling on our superclasses implementation in here when we call on super player character.change hit points, but we're providing additional behaviors that doesn't exist in the superclasses implementation. Okay, so this is called method overriding, and it's just a way to take an existing function in our superclass and change the implementation slightly in the subclass. Now, additionally, if I wanted to go through all the work, I could actually just have copied this and pasted it in and have ignored the super, but why bother when I can just write this one line of code and ignore having to write these extra 4 or 5. With that being said, that just about concludes our discussion on classes in Python. So we started by just talked actually first about what classes and objects are. So remember, objects are the real kind of representation of a particular real-world object. They have state and behavior, and the classes are just kind of the code representation or the blueprint for a particular object. Objects and classes have properties and behaviors. Properties are defined with these variables up at the top here. Behaviors defined by these methods. Now, we use initializers like this to create what are new instances of a class. These are thought of as objects and contain some values for all of these properties. And also, we can execute these behaviors on those instances. As well, we went over the concept of inheritance, which provided a way for a subclass to inherit everything from a superclass. So note that my subclass here has all of these attributes without having to redefine them. But also we can define stuff of our own. So we overrode the initializer here, and we also overrode this extra function by calling on the superclasses implementation and providing a slightly different implementation as well. So these were just a couple of new instances. We passed in the values because we specified that's what we need in the initializers, and then just saw that example of the method overriding down here. You access the functions classes or the classes functions and properties by calling on the instance name .property name or .method name, and you can also modify those properties as well, assuming that these are not private. And we declare variables as private by adding 2 underscores in front, declare them as internal by adding just the 1 underscore, but as much as possible we want to kind of restrict or not restrict that access. So, unless completely necessary, avoid the use of the single and double underscores in front of these variables. One last thing I'll leave you with is a brief, very brief discussion into polymorphism. So polymorphism is important in object-oriented program and basically states that, well, rather in application to our example, it would be the case that our new player character is an instance of game character and player character, which means it has everything game character has as well as everything that player character has. Whereas our game character is not an instance of player character, okay? Game character has everything that it has, but not everything that player character has, okay? But with that being said, we can just about conclude not only our discussion on classes and objects, but our entire tutorial series on the Python language basics. So we started off learning, well, first how to install Python and PyCharm. Then we talked a little bit about the IDE PyCharm itself, how to create new files, how to find the stuff we need to, and then how to compile and run our projects. Then we took a look at simple variables in Python. There were the 2 main single variable types, the numbers and strings. We took a look at multi-variable types, which were our arrays, tuples, and dictionaries. Then we explored control flow. We talked about if statements, else if or elif, and then else statements. Then we talked about our while and for loops, then moved to functions, and finally finished up with our discussion on classes, which is what we talked about here. So I know things went kind of quickly, and I didn't go too in-depth into a lot of these topics. There's still honestly a lot that I wanted to discuss, but I'm trying to just give you the basics as quickly as I could and get you out there and ready to develop some actual programs of your own.